Good afternoon, everyone, and especially very good afternoon to all the distinguished speakers, the faculty members, and to all the young brains of India. Imagine a scenario. Imagine yourself going to a different city, which is not at all known to you. In today's scenario, you go to these cities very confidently because you have the GPS or the global positioning system with you. Okay, I want to go from point A to point B. I'll utilize this system. Now imagine another scenario. We are flying in the aircraft, close to 350-400 sorties for a day. All these aircraft leave around the military aircraft, the civil aircrafts also. They are heavily dependent on the GPS system, the global positioning system. To bring out two scenarios, first of all, I switch off my GPS. Imagine that scenario, every flying object in the air going without direction. And to worsen the situation, especially in war, I'll feed wrong coordinates to these flying machines. That is more dangerous. With this, I introduce my topic of presentation. Can you have the presentation, please? That is aircraft real-time tracking using the IRNSS. That is your Indian Regional Navigation Satellite System. Since I understand the people are from all the disciplines, so I'll be covering the basics of it, followed by I'll try to pitch in this presentation in the simplest way possible so that it can be grasped by all the people. And at the end, I'll try to come to a point how fruitful it is for every discipline also in the future. So I'll be covering my topic under the following heads. What is IRNSS system? The necessity for indigenizing your own navigation system. The real-time aircraft tracking system, what actually the system is. Whatever field trials we have conducted over a period of last 4.5 or 5 years. The comparison with the established GPS and the differential GPS system. The advantages of having your own navigation system, the various applications or the future potential of these satellites which has been launched at a cost of close to 2,500 crores, and the present status of the Indian Air Force on the implementation of IRNSS system on the aerial platform. Basically, the IRNSS consists a constellation of 7 satellites which are placed at an orbit of 35,000 kilometers from the surface of the Earth. These 7 satellites can be further divided into 4 geosynchronous and 3 geostationary, which covers your entire Indian region. It provides an accuracy close to 10 meters within India plus 1500 kilometers. I repeat, plus 1500 kilometers around India with 100% integrity. That has been tested on the field trials. If you look at any, you call it global positioning system or per se the IRNSS system, it has 2 types of services. The first one is which is available to all the people, all the users. We call it standard positioning services. That means I can use it, anybody in this room can use it. Because their codes are known, their ICDs are known to everybody, it has been made in the public domain. And the second thing, which is of the larger interest to the defense forces, are the restricted services. If you take it in the GPS parlance, it is called your L2 frequency, whose codes US never shares with anybody, even with the military forces also. But with this, we are having our own restricted codes or the confidential codes, which is for the pure military or the confidential applications. Basically, these satellites operates on 2 frequencies, L5 and the S-band. I'll not go into much of the details of it, but just to remember L5 and the S-band in this. And the system, as I have covered, it provides an accuracy even for the normal users of 10 meters, but the trials have proven that we have conducted close to 70 hours of flying. And the results, what we have obtained is the results were better than 5 meters for the Indian system. What IRNSS is, basically it consists of your 3 segments. One is the space segment. One is your space segment. That is, I was talking about those 7 satellites. Second is your ground segment. These satellites require course correction. They deviate over a certain period of time. The integrity monitoring. So these satellites are being controlled from the ground, especially from Bangalore and the area around Bangalore. And one of the hubs is in Space Application Center, that is your Ahmedabad only. And the third one is the user segment, that is you, me, anybody, which consists of your ground objects, aerial platforms, sea applications, endless opportunities are there. These were the satellites which has been launched from 2013 till 2018. Now, anybody, it's a very, very natural question. Actually, I did my MTech from Indian Space Research Organization. So when I was going, my topic of specialization was Global Navigation Satellite System. So initially I thought, why to spend close to 3,000 or 2,500 crores on having your own navigation system when you have your other navigation systems which are well established, that is GPS, GLONASS, Galileo, they have established, they are world-class players. So why unnecessary to spend public money of 3,000 crores? First of all, the GPS is a foreign controlled body. At any point of time, if you want to tweak the satellites, it's very much possible from the ground. We have faced one of the situations in 98 Kargil war, where when we were attacking Pakistan, we were asked US to share their confidential frequency, that is L2. L1 is known to everybody. We are using L1, that is how your GPS are operating. We have asked that, they have denied. They told it is for their specific applications. And just to keep the talks here, they deterred the frequency. The heart of any satellite is the atomic clock. The frequency of vibration of these atomic clocks can be varied. Once you vary that, the accuracy can be varied. The difference between this clock and your atomic clock is, this clock drifts by 1 second in 24 hours. But your atomic clock differs by 1 nanosecond in 25 years. That is the specialization. India still don't have a specialization in designing the atomic clocks. But after the failure of the satellite number 7, we have started these initiatives. So this is one of the fields which the people, especially from the engineering faculty, they can ponder this point upon. The indigenization of our own atomic clock, which is a hot and the current issue right now. So they deterred the frequency. So with that, the accuracy of what GPS we were using on the various attack platforms, we were thinking we were firing at the correct position, but it was falling at some other place. And India lost it 40% of the ammunition, 40%, just it was wasted. Just because the frequency was deterred. This is a case in 98. Then in 2002, if you track the history of this, in 2002, US got afraid because since they deterred the frequency or they varied the frequency, because military is a very, very small market for any navigation system. So they thought their market will be disturbed. So in 2002, they have published one of the articles known as Essay, Selective Adaptability, in which, just to tell you the crux, they declared we are not varying any frequency, our system is 100% guaranteed, and so many things, so that their market is not disturbed. You track 98, you track 2000, you would be able to link both the things. That was the time ISRO decided that we will have our own satellites. And this project started in 2007. 200 scientists, they worked continuously for 8 years and they made the first launch. They decided in 2006. they told we will do the first launch in 2015. I've seen those things practically, and they made it possible. So it was up to us after that, once they have done it, how to apply those things for our military applications as well as for the civil applications also. Second, the RS services. There are certain applications which requires high confidence. If I'm going to carry out certain attack on Pakistan, I require those codes to be secret. It should not known to be anybody. Even for the per se, if I'm not there in the mission, it will not be known to me. That is possible with your own regional navigation satellite system, nothing else. Otherwise, other GPS or Galileo, Europe, US, they will not give you these secret codes. So your accuracy is quite compromised. Gentlemen, coming to the third point, operation, we have a fleet of close to 1100 aircraft. Out of those, 500 aircraft are of the legacy fleets. We are flying these aircrafts in northeastern region towards the China border, towards Kargil. So the real-time tracking, and most of the time what we do when we fly in certain operations, we switch off the GPS so that we are not being tracked. With our restricted services, we can continuously use this. And imagine a scenario, I've put off my GPS. If something happens to my aircraft, nobody would be able to track it to me. The same thing came in 2016 and 19, where unfortunately we lost 2 aircrafts, one in Andamans and one in Northeastern. That is one of the aircraft of Jorat region. Andamans, the aircraft could not be located till date. And the wreckages of the Jorat aircraft was recovered after 21 days, though we know the area is only 1.5 or 2 kilometers. So what is the advantage of this system is, it has a small circular error probable. That is, if I tell you somebody, if he or she is sitting over there, locate so and so guy, you have to search for 10-15 minutes. But if I tell the correct position, you would be able to hack it in 5 seconds or even lesser. So the area of search reduces drastically with the reduction in your circular error probable. That is one of the advantages. With a GPS, you have to search anything with an object which is flying at a speed of 450 kilometers. You have to search something in the area of 2 kilometers. But with our own satellites, you have that area of 50 meters only or 60 meters. That search space has reduced almost by more than 10 times. In today's scenario, you have your GPS, which gives you the real-time tracking of the aircraft also. But right now we are using the Inmarsat satellites. These are the British satellites. One is you are taking the position from the GPS that is getting processed somewhere in Singapore, and that is being displayed on the screen for right now where we are monitoring the aircraft. So this comes at a delay of 35 or 36 seconds. By that time, my aircraft has traveled, the Su class or the fighter class of aircraft has traveled by 5 or 6 kilometers. With our own indigenized or the real-time tracking system, we are able to track our aircrafts every 4 seconds. Every 4 seconds, gentlemen. And this frequency can further be reduced to 1 second or 0.5 seconds. But the only thing is, it will eat that much amount of bandwidth, which we don't have a dearth of. High accuracy, we are using 2 frequencies, L5 and S. So what it does basically, it negates your ionospheric error, which is a main source of error in the GPS positioning or IRNSS. With GPS, you are using currently only 1 frequency, that is L1. So the error is close to 60 or 70 meters. You may not realize it because you will see the object in front of you. Okay, cinema hall is just over there. But the error in the position is close to 60-70 meters. So when you are dropping a bomb, when you are carrying a high confidential mission, even 1 meter becomes important to us. With this IRNSS, even the normal user can have an accuracy of close to 5 to 6 meters. When I did my MTech in 2016, in the entire globe, these things were not tested on any of the aerial platforms. So all the discoveries are made by accident. So I was sitting with the director one of the days, Space Application Center, he asked, will you do the trials? Let's say we can try. And as compared to the ground vehicles, we have to design certain receivers which are vary in your dynamics, your frequency, your update rate. So we took the modification and we took the maiden trials without getting the official clearances. There are certain people whom I have worked with, they have favored, but we have flown the sorties for 18 to 20 hours. We got very fruitful results. The thing would have been, I would have waited for 6-7 years. Okay, somebody will take an initiative. After 6-7 years, the aviation qualified antennas will come to the market and then I'll start using it. So I'll lose these 6-7 years. After 6-7 years, I'll discover, okay, these things are lagging in the present system, let's go ahead with the modification. So this is a kind of endless process. And gentlemen, let me tell you, these satellites have a life of 6 to 7 years only. Every 7th or 8th year, you have to launch a new satellite to maintain this constellation. Cost of every satellite, 500 crores. So you can imagine the amount of the time and the amount of the public money we are losing when we are losing every second of it. We did the trials with the IRNSS. We compared the result with the GPS system. We have our aircraft installed with the GPS system also. So we took out that data also because it's an established system. We compared with the IRNSS and the differential GPS system. What you call is the Gagan. Gagan is nothing like a GPS. It gives you the data. It gives you the position. We have certain error correcting station in India only. It corrects its position and feed to the users. But that will again not work if your GPS is off because the source of the data is GPS only. That is your differential GPS or the Gagan system is. We assess the data. Luckily, I was there when these satellites were getting launched. So minimum 4 to 5 satellites you require for your tracking or for the position determination. So we assess the data with 5 satellites. After 6 months or 7 months, 7th one was launched. Then the 6th one and followed by the 7th one. With this, the most important it is beneficial in the long term. In the world of anti-satellite weapon technology, your satellites can be shot down also. So for example, in the worst possible scenario, if your 6th or the 7th satellite is being shot down, would I be able to undertake my flying or not? Those data also we collected. Coming to the real-time aircraft tracking system. Just to explain you in a very simple way, these 7 satellites give you your position. For example, if I am standing here, these 7 satellites are above me. It will determine my position. When I am flying, it will give me to the aircraft. Real-time tracking system, how it's get implemented, you transfer whatever coordinates you are receiving on the aircraft to the ground so that you can track me over the ground. That is a basic, very, very basic concept of real-time aircraft tracking. So it consists of basically 2 antennas. One will receive these coordinates. One is your terminal, which we have designed it. It will process the data and through the other antenna, it will transfer the data to the another communication satellite, which will relay it to the ground. And this entire process takes place in less than 1 second. This is a pictorial form. These were the black one. What you can see is the antenna which will receive your coordinates, your latitude, longitude, and altitude. It will get processed by this two-way MSS terminal, and in turn, it will relay the white one. What you can see, it will give the data to that antenna, which in turn will transmit it to the GSAT-6 satellite. And I can see the blips on the ground like this, what has been indicated. These were the initial trials, what we carried out in a very, very rudimentary way, because in 2016 nobody has given us the clearances. Once we made the move, afterwards these clearances were regularized. We have also learned a lot of things in the process, but still I thank to all my seniors who have supported the cause so that we have not lost this 5 or 6 years. So we have put in these antennas. The black one on the left hand side, it will receive the coordinates. This the dotted one, it will process the data, and the white one will transmit the data to the another satellite so that I can see those coordinates flying on the ground. These were the actual positions where we have positioned these antennas. Gentlemen, as I covered, we have flown close to 72 hours. So we have tested your GPS system also, your differential GPS, and the performance of IRNSS also. This is the summary of all the trials. In a very simple way, I'll tell. We have assessed the data of the satellites in terms of your how many satellites are available, what is the signal strength, what is the DOP value, dilution of precision. Briefly, I will cover it at a later stage. If you see the results obtained for the GPS IRNSS system, the top row, it gives you a horizontal accuracy, how much left or right I am. So the accuracy has come close to 1 to 2 meters. The next row, if you see the GPS system, it has come close to 2.5 meters. But there is another, the world is of the global navigation satellite system right now. If you have 5 satellites, I have 5 satellites, let's combine it and do the business. So the receivers, what we are designing these days, it will have your GPS capability, because if I am flying close to US region, I'll switch on to GPS because it will be more accurate over there. If I am flying in the Indian region, I'll switch it to IRNSS. It will be more accurate. Or I can combine these satellites. I can make it 5 plus 5, I can make it 10, and I can use it where I'll have a better accuracy. So the third row gives you a much better results. And the last one is your differential GPS, that is your Gagan system. This is one of the clips. The red line indicates this is on the top. We were, prior to the takeoff, we were aligning the aircraft. So we have turned around the aircraft to line it up. And the second is just when we landed. So the red line indicates the performance of your IRNSS system, and the cyan line or the blue line indicates the performance of the GPS. If you can see here, it has some zigzag lines also. That is not basically possible. We cannot maneuver the aircraft like this. It has to follow a smooth course of action. So this is where the position went wrong. After landing also, hardly we vary the runway center line by 1.5 meters. It is showing us the variation of close to 10 meters. Whereas your own IRNSS system has shown the correct results or the actual results. The dilution of precision. In very simple terms, it is the geometry of the satellites. What it makes with respect to the user, the better is the geometry, the better is the position accuracy. And the value is ideal is close to 1. So this parameter is being utilized for your position calculation error. So for the IRNSS system, we found this value close to 3.2. These sudden spikes are basically when we were changing the attitude of the aircraft. Another field of interest for the engineers or even for the marketing people here. Before carrying out the field trials, we have imported some of the simulators from abroad, costing close to 2 crores or 3 crores. This simulator does a function. You put an input of the field or the airfield where you are going to fly, the temperatures, everything. It will give you that DOP value. But it is a theoretical one. Once we fly, you can compare the results. So this is an indigenization, what we are looking in the current scenario, the indigenization of these simulators. Then the another aspect is your signal strength. For the GPS or any navigational system, your signals are very, very weak. If you lose the signal, you will lose the coordinates. So performance was found quite satisfactory over there. Continuous availability. You see here the continuous availability of 7 satellites were there throughout the period of operations. So better is the number of satellites, better is the position accuracy. This is where the global navigation system is coming into operation. Here we have combined the satellites of GPS and the IRNSS system also. So if you see, the average number of satellites on the right hand graph is close to 17 to 18. That is how the results were better. Coming to the advantages of our system, as we have proven a better horizontal and vertical position accuracy, drastic reduction in the circular error probable, that is your search area, which is quite critical or vital in the military operations. We can program the data in case we want to increase the update rate. Okay, if 10 aircraft, the fighters are flying in the enemy territory, I want an update every 0.5 seconds, not 4 seconds. I can reprogram that data rate so that my aircrafts are visible on the screen, and accordingly we can take the calls. Restricted services we have tested and it has come out good. Anti-jamming and spoofing. Since you are operating in two bands, that is L5 and S, these are the two extreme bands. In today's scenario, in GPS, if you want to jam, you just require a 5-watt jammer because you know the frequency, you know the power, and people have done it. They have jammed the system and they have spoofed. By spoofing, you means you feed in the wrong coordinates to a person, he will take it right. Okay, these are the coordinates and I'm going correct. That is a word or the term used as spoofing. IRNSS application, these 7 satellites have been launched and the number of applications are there. The first is your position determination, which we have derived in. The second is aircraft real-time tracking system. And the remaining 3 applications still we are working at. I'll be covering in brief. The strategic messaging is like when you don't have a communication on the aircraft. For example, if I'm sitting on the ground, my RT is jammed, I am flying, and if I want to give you certain instructions from the ground, my VHF is jammed, my high frequencies are jammed. At that point of time, the strategic messaging can be displayed on the cockpit screen. Okay, you disperse, you continue with the mission, you abort the missions. There will be customized messages, what we are working at right now. ADSB, all the ATCs, whenever you go to any airport next time, just have a look. There are primary and the secondary radars which are guiding your aircrafts. The primary is like it works on the reflections, and secondary is you interrogate certain aircraft, it will reply to you, okay, I am so and so. By the use of these satellites, you can let go your primary and the secondary radars in the future. You are receiving your coordinates on the aircraft, directly you can transmit those coordinates to the ATC. So the major juncture of primary and secondary radars can be let go. We can get rid of, because these systems, they have become old, requires a lot of maintenance. Another application, Global Aeronautical Distress Safety System. Most of you must have been aware of MH370, which happened in 2014, where the aircraft could not be recovered till date. So many theories came out of it. The last position, maybe some people say the pilot has switched off the RT because it was a kind of suicidal. You just read about MH370. It will give you a plethora of material on that. This system, basically, even if the pilot or the crew does not transmit its position, it will transmit by itself every 10 seconds, every 1 minute, every 10 minutes, depending upon the kind of emergency, it will automatically transmit, okay, I'm okay, these are my last coordinates. So it does not require any human interference to give your coordinates, so that the search and the rescue missions can be carried out accordingly. Coming to the last or second last slide, I'll say. The project status, we have flown close to 72 hours in last, we have carried out these trials for last 5.5 years. So we have flown in Kargil, towards close to the northeastern region, southwestern, every part of India we have covered up. So what we found, the accuracy was good, restricted services has been checked, and with ISRO we have prepared the design document, and right now we are developing the first prototype in one of the major bases of Indian Air Force. With these prototypes, we'll be flying our first aircraft in the month of May or June. So right now, there are 2 companies which are bidding for it. In today's scenario, you have GPS, where over lakhs of manufacturers are there. Ladies and gentlemen, just see from the business potential also. If you participate in this technology, right now only 2 companies are working. In the future, you have your military aircrafts, civil aircrafts, army, navy, air force, civil applications. Everybody will be using the IRNSS system. So the students who are especially in their final year, planning to start up their own setups, this is one of the viable fields which you can look into. This is where we are going to install the antennas, the 2 antennas what I was talking about. This is the 2D view. And there are some internal structures, modification, what we are going to carry it out, just to give you a glimpse of it. Conclusion, now we are working towards making a portable set. There are certain aircrafts in India which you can modify, you have the authority. But the new inductions like C-17, C-130, Hercules which are going to come up, you don't have the authority. You have to approach the OEM which charge 10 times of the amount. So we are trying to develop a portable sets also. So it can be placed, it increases the interoperability. I'll make 200 sets and I'll place it in any of the aircraft. So this is the project which is currently going on. We are trying to integrate the flight data recorder parameters. Once you lose any aircraft, the first thing you look for the black box, what you have heard of, ki black box dhondo, because it contains all your critical parameters, your flight controls, your engine parameters. So likewise, when you are transmitting the position, we are planning to transmit these critical parameters 8 to 10 after every 1 or 2 minutes, so that you need not to search for your flight data recorders also. Whatever positioning we are determining these days, still we are not using our own maps. We are using the Google Maps. What sir has brought out in his the last speaker, what sir has told, these GPS maps does not recognize your line of actual control. This is Pakistan occupied India, but your own indigenized map very well identify these things. And these maps have been designed by the ISRO. So the expression of the interest for getting the devices with the Bhuvan maps, we are going to float very, very shortly. And anybody who is interested in this, they can approach me. We will tell you how to approach air headquarters, how to look for these things, what we are looking for. Very simple. It may take time, but once you experience, being in the Air Force, it took me 6.5 years to implement this project. But it comes up. So especially for the youngsters like you, this is a new technology. Please pitch into this. So use of indigenized map known as the Bhuvan maps, which has been developed by the ISRO. Highly accurate maps. This is what we are trying to get into our display systems. The government of India is planning to launch their 8th, 9th, 10th and the 11th satellite by 2025 or 26. So this will make our system from regional to the global, like same as the GPS, BIDU or the Galileo systems. So the possibilities I wanted to say are endless into this field. And this is a major big push. Your own Indian industries are working into it. Your ISRO department, Air Force department, your own maps. Nothing has been outsourced. So this is a big push to the Make in India project also. So what I request, if you participate in this, or in case you participate in any of the development project, it will be a big boost for the defense or the armed forces.